All right, welcome back. It's Mr. O again. This is Unit 3, Lesson 4. This time we're going to take a look at things like increasing and decreasing, as well as stuff we already know from max and mins and intercepts, etc. But we're also going to deal with stuff over certain intervals. And if you notice in this equation here, we're starting right off on that first page here, you've got y equals the function of x. This one's tougher to describe because if you can take a look, it's going up and down and up and down. And this is basically called a polynomial function. A lot more complicated than anything we're going to do. And you're not going to actually be drawing one of those that complicated as much as just being able to read the graph. Notice they said right here, it's over this interval from -7. X has got to be bigger than or equal to that, but only up to or less than or equal to basically 7. So we're only going to go from one point here, work our way through this whole thing up to this point. We're not going up to 8. We're not going out here at -8. So you've got an interval. It's called a restrictive interval that we're going to deal with. Okay. So in part A here, first of all, they want to know what's the maximum. Well, if you take a look at the graph, where's the highest point on the thing? Way up here. So that is our maximum, and we will write that down. The max is basically, if you take a look, 1, 2, 3, what do we got up? 3, 4, 5, 6, 7 is our height. So we're going to go with a max of 7. Okay, and where is our minimum? It is way down here at down this one at a -1, and it looks like so you've got a point of 1, 2, 3, 4, 5. So -5, -1. So we can also do that too. So our min is at -1. If you want to, and they actually ask for the coordinate, then this one actually was at -1 up 7. And this one has a minimum of -5 down 1. That's our minimum on the whole thing. Okay. Where's the y-intercept? Well, of course, that's where this thing hits. Here's our y-axis right here. Okay. Where does it hit? Right at this point here. I'm a little bit off on my hand-drawn graph, but it's going to hit that point. So it looks like we got a height of 2, 4, 6 is our y-intercept. If you have to call it a coordinate, obviously we're not going left or right, so it's 0, up 6. What's our x-intercept? Well, that might be a little newer to you here. X-intercept where it hits the x-axis. And it actually hits twice, right here and right here. So at -4 over and at -6. So you got two x-intercepts. So -4 and -6. Both are your x-intercepts. You got more than one here. All right, when we go on to part D here, it says, would you characterize this function as increasing and decreasing from the interval from -5 up to -1. Well, if you go over to -5 here, we're right here, and we got to go to -1, which is here. We go up here. It's going from here to here. Well, you guys can clearly tell, going from -5 up to here. What's it doing? It's going uphill. So clearly, that is an increasing interval. Okay, so you would write increasing in there. That's your first look at increasing or decreasing. If it was going downhill, it would be decreasing in that function. All right, part E says, give us another interval that basically states that it's increasing. So we already have conquered this one going up. Where else is it going up? Well, I see it going up basically over here too. Okay, so if I take a look, I'd go from this point right here. I know I'm off a little bit here, going up to there. So it looks like what? From a -2 up to over to 1, 2, 3 more. So 5. Sorry, from 2 to 5. That's going uphill. So how do I write that? I basically say, hey, it's increasing from 2 less than or equal to x less than or equal to 5. What that really means is x here is bigger than or equal to 2, but yet less than or equal to 5. So that will cover that interval going up. Well, where's it decreasing? You got a lot of choices on this one. If you notice, it's decreasing over here. You could pick that one. It's decreasing from this one down to here, and it's decreasing from here. So it's just a matter of which one you want to pick. You know what I'm going to do? I'm going to take this one over here. So let's pick that one, and we'll write a decreasing interval. So it is decreasing basically from -1. X is bigger than or equal to -1. At the same time, it has to be less than or equal to 2. So that will cover from -1 right here all the way down to 2 here. That's a decreasing interval. Right? And like I said, there's more than one answer you guys could have picked. In the final part here, part F, they're asking you what each of these points are. Well, are they mins or maximums? Okay, relative. When they say relative, it means is it one that's actually turning in that. This is a relative max here. This is a relative max, but actually this turns out to be the absolute max for this whole function that we can see in the interval. But relative means either one. So let's try to find out where we were going to go. So we want -5, -1. That's this point right here. What do you guys think? Definitely at the bottom. It turns and goes back up. So that's going to be a minimum. This guy right here from -1 up 7, we already know is our max. Then they've got 2, 2. Once again, it's at the bottom of a curve, so that's going to be a minimum. And this guy's going to be at the top. He's going to be a max. So we can fill those answers in just like that. This guy here was a minimum. Then we got a max. Then we had another minimum. And we had another max. Okay, so you can circle those answers on your paper. And then we're going to move on to example number 2. So pause and flip the page. All right, example 2, we got another piecewise function we learned just like the other day in lesson number 3. There's a couple parts of this thing. If you take a look, after you do x plus 3 whenever it's less than or equal to 1. And according to this one, 6 minus 2x whenever x is greater than or equal to 1. If you notice down here, I put a couple dashes because isn't our key piece right here 1? So I'm watching this part right here. This is where things change. There's 2 pieces. There's one part over here, this whole thing when I plug in those numbers, and there's another one for this stuff down here. So we're going to take a look at 2 different pieces, plug our stuff in, and away we go. So if I plug in -4 here first, that's the first one they want us to plug in. You got to take a -4 plus 3, and once again, why am I doing this? Sorry about the writing here. Because the rule for the first part is right here. This is what I'm dealing with. X is plus 3 for anything less than or equal to 1. So if I deal with that, I'm going to actually get that. So -4 plus 3 actually turns out to be a -1. Now, you'll notice this time I did not do an X comma Y. If you want that column, by all means, add another column here, and you can put it in and say, hey, this is -1. Sorry, -4 got plugged in. -1 was my output, and that would be your X comma Y. I like just doing an X and a Y column with the work in between because I know I can read the table. But for a lot of you guys, it's much better to put it together. So when you go to graph this, we'll be in great shape. Okay. So next you would plug in a -3 and you would add that to 3 and you would actually get 0. You plug in a -2 and you add that to 3, you will actually get 1. Plug in -1, add 3, you'll get 2. Plug in 0 onto 3, you will get 3. Okay, so if you're filling in this right side here, that would be 0 comma 3 would be an our point. You can fill in these other ones right here. All right, so the big one is 1. Well, they're both equal to 1, so the only thing you can do, it must work for both. So I'm going to show you both. The one is you got to take the 1 plus 3, and we would end up getting a 4, wouldn't we, if we did an equal here? All right, but look at the new function here. If I change my colors here, I'm going to the red. If you take a look at the other one right here, it says 6 minus 2x. So if I actually do a 6 minus 2 times 1, okay, well, what is 2 times 1? It's 2. 6 minus 2 would also be equal to 4. So you notice either way you get the same answer, 4. So both of them are 1 comma 4 either way. All right, but the rest of them have to be done with that new function because all these points right here are greater than or equal to 1. So you have to do 6 minus 2 times 2. So that makes 6 times minus 4, okay, which is 2. Then you plug in 6 minus 3, 2 times 3. So that's going to turn out to be equal to 0. And finally, the last one, 6 minus 2 times 4, you're going to actually get a -2 out of this. All right, that's our piecewise. Bottom line here on the piecewise is we got one set of numbers here, another one here. You notice the whole time we stayed consistent going up. But over on this side, we're going increasing here, and now we turn around, we're going down. So it's going to be 2 separate pieces. Let's go on to the next page, and we're going to graph this baby. All right, now time to create this. You can graph this piecewise. So we said the first point was -4, -1. I put a point right there. Then -3 is up 0. Then -2 is up 1. -1 was up 2. All right, 0 was up 3. And then 1 turned out to be 4. Okay, so that's the one piecewise piece. Then the other one also had 1 being 4, but then 2 turned out to be 2, 3 turned out to be 0, and 4 turned out to be -2. So we got 2 distinct pieces that go. One goes from here all the way up, and the other one drives its way down here. So two separate pieces for this function. Once again, we called this function y equals f of x. And yes, we did have some pieces in there. You could actually do the f of x part and tell me the x plus 3 and all that. But that's the bottom function here on this. So the graph is all set and ready to roll. Now when we proceed on to part B, we actually are going to take a look here. And it says in part B, state the zeros. Well, where are the zeros? Once again, zeros is where it hits this x-axis. So I got a 0 right here, and I've got a 0 right there. So 1 at -3 and 1 over +3. So those are your two answers when you're drawing on this one. Coming up the zeros. What's another fancy name for the zeros? The x-intercepts, of course. So what does that bring us to? 1C, they want to know where's the y-intercept. Well, there better only be one, remember, if it's a function. So it's got to pass that vertical line test. Cannot have multiple ones. Well, the y-intercept, change my color here, I'll go to green, is right here. That's where it hits. So how far is 0 up 3? So we normally say it's 0, up 3. All right. Then we go to part D now. They want to know, give us an interval where things are increasing, where they're decreasing. Well, clearly, it's increasing going this way. So if we start out here at the -4 and we go all the way up to 1, over to 1 here, it's going all the way up all the time, isn't it? So if I go and draw that one, it is increasing starting at -4, less than or equal to x, and it goes all the way up to 1. Then, if I want my decreasing, it actually is going downhill from the 1. Okay, so as you can tell, it actually was the second part of the piecewise. So I'm going to go downhill here. So at 1, less than or equal to x, coming all the way down till where it stops there over at 4. It comes down to 4, -2. So from 1 to 4, this baby is going downhill. So increasing here, decreasing on this part. Those are the two separate pieces. That was part D. Part E now says, give the coordinates of one turning point and classify it as either relative max or a min. Well, if I take a look here, this is my only real turning point there, guys. And of course, you see that it's at the top of the hill. So they want the coordinates of that thing. So the coordinates on that one will be 0, not 0, sorry, 1, up 4. And of course, that is a maximum. All right. The next piece that they want to know here is they want to know where is this function here equal to 2. Well, we want to know where does it hit equal to 2. Well, there's a couple spots. You got to go up here where x is equal to 2 and go across this line. It hits right there. It hits right there. So where is it equal to it? At -1, it's up 2. And also it hits over at 2. Those are the two spots right here at 2. Right here at -1, they're both up a height of 2. That's where the output comes out to. Last part is, where is this thing a positive interval? Well, you guys should know that positive intervals are anything that's above the x-axis. So anything above this line right here is positive up here, and anything below has a negative value. All right, so that's for the outputs. So where's our positive interval? Up here. Well, where did it start? Right here. So you got to start over 1 to -3. And it goes all the way to +3. Steve stays in our positive above the x-axis. But keep in mind, 0 is neither considered positive or negative. So I'm going to have a little thing I'm going to deal with here. And when I'm writing this, yes, I have a -3, and it goes up to 3. Remember, you put the x in between. But notice, no equal to bars, because that's not positive at 0. Anything a hair bigger than -3 is positive. Anything a little smaller than +3 is positive over here. All this is positive. But right here, that's 0, and that one is 0. Anything to the right of this is negative. That's negative. So this is my positive interval from -3 up to 3, but not including them. So no equal to bars, all right? Well, that's our lesson for today. You learned a bunch of things on increasing, decreasing, where positive intervals are, the zeros, the x-intercepts, the y-intercepts, once again, how to read points off a graph and all that, create the tables for any functions, even these fancy piecewise ones. And so it's your turn now to write a nice WSQ. Hit those high points that I talked about, get them in the WSQs, and we'll see you in class tomorrow.